Welcome to the Outback. We've gone down under to take a ride on a massive train that travels over 4,300 kilometers across Australia.
A few shrubs, no trees, completely barren.
It's an epic adventure through some of the most scenic and remote areas a train has ever gone. Whoa, it is very steep. Woo!
The 4-day coast-to-coast journey goes across remote farmland and a scorching hot desert known as the Nullarbor Plain.
There's nobody there, anything can happen.
Get ready for the Indian Pacific.
Australia is home to some of the most desolate and harsh landscapes in the world.
This is typical Australian bush out here. Pretty hot, dry and desolate. As we call it, the harshness of the bush, but yeah, it's beautiful.
Train passengers flock from all corners of the globe to experience this sizzling, barren continent in total luxury. It's 6 a.m. at East Perth Station, and a small army of technicians, attendants, and service staff has just 4 hours to get the giant train ready for departure.
The Indian Pacific is massive, almost a kilometer long, and it gets its name from the route that it takes, starting at the Indian Ocean in Perth, traveling all the way to the Pacific Ocean in Sydney.
Terminal manager, Anne-Marie.
Evening, Bruce.
He'd prefer K1 because it's in the middle of the train.
Running the operation is 23-year veteran of the rails, train manager Bruce Smith.
From the back of the loco to the back of the train, that's my jurisdiction. I'm in charge of the crew, the guests on board, and making sure everybody's having a really good time.
Hey there, Bruce. Teddy, how are you? So it's a really long train, but how many passengers do we have on board?
We've got 240 passengers today, Teddy.
Wow.
Yep, it's pretty full.
And we're leaving pretty soon, so what's on your plate right now?
A lot of operational issues with the driver, getting the signal to get going, guest issues, making sure everybody's in their right place. It's like a big jigsaw puzzle.
Big is an understatement. The train is a whopping 30 carriages long. The motor rail, a crew car, and a power van are at the front. 16 accommodation cars are spread throughout, with 3 restaurant carriages and 2 lounge cars to relax in. At the back of the train is the luggage car and a second power van, so there's no shortage of electricity. This 775-meter train is longer than 7 pro-American football fields.
There are 2 different categories or classes on the Indian Pacific. There's gold class and platinum, and this is one of the platinum rooms, and as you can see, it's really, really nice. The chairs fold down into a bed. There's a full bathroom with shower, and a lot of attention to detail goes into this.
This cabin costs up to 4,500 Canadian dollars per person. And for a few hundred more, passengers can add a unique piece of cargo.
A cool feature the Indian Pacific offers over other passenger trains is this special wagon. It's called a motor rail, and as you can see, it's designed to haul cars. We've got 8, so it's a full load on today's train.
David Barnett makes sure every car wheel is properly clamped.
Good. Always make sure that the pins are secure, because if the pin's not secure and the train's moving and jerking, the vehicle could just easily smack into the back of the next car. Yeah, these things could be like, you know, a weapon. Could wipe out a whole train.
In November 2017, the motor rail did jump the tracks just outside Perth Station while moving at 10 kilometers an hour. Maintenance crews had the train running again 12 hours later.
Fortunately, lucky that no one got hurt and all the vehicles were still safely clamped down. Once they're all clamped down, we close the gates. The loco will back up, take it, and hook it onto the front of the train.
With nearly a kilometer's worth of carriages being pulled behind, there needs to be some serious muscle up here at the front end to make the Indian Pacific go.
That muscle is a 132-ton beast coming from a fleet of Pacific National Rail locomotives. It's 4.25 meters tall, 2.94 meters wide, and 22 meters long. A turbocharged 16-cylinder engine delivers 4,250 horsepower, which is needed to pull the 1,400-ton luxury hotel across Australia's harshest landscapes. Before any locomotive can depart, drivers must give their engine a complete spot check. Our driver, Paul Lawrence, will have to take care of the train if anything goes wrong.
Got to make sure all the fuel's ready, all the brakes are done, top up any oil, any other provisions that have been used on the way. It's one of the most remote places there are really in the world for the train travel.
Paul's been driving across Australia's remote terrain for nearly a decade. He knows how a journey through the middle of nowhere can wreak havoc on his train.
You do get a lot of variety of animals and different things out there. Bigger animals can tend to do a lot of damage to all the brake pipes and get a lot of air leaks. And if you get a big air leak, you can apply the brakes to the train and they'll have to fix that before they can continue.
In the desert-like outback, temperatures can exceed 40 degrees Celsius.
That's all the condensation that builds up in the air system.
And can drop to 10 degrees the same night. Those wild temperature swings turn air inside the pneumatic brake pipes into water.
Make sure there's no water in the air system, otherwise the brakes won't work properly. This is the compressor, what gives us the air for all the brakes for the train, for the locomotive, make sure we can stop. If we have a compressor fault, we get no more air pumping through the train. Basically, we'll be stranded. We won't be able to go anywhere until it's fixed.
Only with Paul's sign-off can the locomotive report to the station, ready for action.
It looks all good on this locomotive. Should be all good to go.
At East Perth Station, Paul couples his locomotive to the rest of the train.
Did you know how to keep the door open or just lock it up, over?
Leave it open until the duty manager goes through and secures it, mate. Over.
At 7:30 a.m., the check-in desk is open for passengers who are arriving by the busload.
Good morning, how are you today? What name were you booked under?
Attendants have just 90 minutes to check in all 240 passengers and their 4 tons of luggage.
Oh, hello. How are you?
Our train manager, Bruce, has just 25 minutes to run his final checks before we depart.
This is my lockdown sheet. It tells me which hospitality attendant is on which door, so they have to lock and secure it.
Bruce's deputy duty manager, Penny McNamara, performs that final cross-check up the entire length of the train.
And making sure that everything's secure and not going to flap open while we're moving at track speed.
Duty manager, NR29.
NR29, duty manager calls receiving over.
We have a light up here or on the route?
Yeah, we should be right for an on-time departure today. We're just in our final stages of our lockdown. Thanks, over.
And we're off.
Good morning, ladies and gentlemen. Welcome aboard the Indian Pacific.
My 4,352-kilometer journey has begun. From Perth, we're rolling east on a single-track line across the state of Western Australia. After a stop in Kalgoorlie, we'll trek 1,000 kilometers across the isolated Nullarbor Plain. After rounding the Great Australian Bight coastline, we'll make a big stop in Adelaide, before heading into the state of New South Wales to scale the Blue Mountains. We'll arrive at our final destination of Sydney 4 days later.
We're just pulling out of the train station here in Perth, so our trip has begun. I'm so excited. We're going to cross an entire continent, multiple time zones, 16 different natural landscapes. It's going to be epic.
Unless the wild Australian outback gets in our way.
Control, yeah, receive.
I don't know if you're aware, something happening over on the desert the other side of Park.
I've been here 23 years and yeah, this will be the worst one.
Oh, Thank you, Samina.
You're welcome.
50 kilometers out of Perth, and the landscape is shifting from coastal bushlands to outback farms. The first onboard meal is lunch. Keeping the food at 5-star quality means chefs are masters of cooking on the move.
Every year, the Indian Pacific serves over 715,000 dishes. They're all made in kitchens like this one. There are 3 of them on this train, and they're made by chefs like Michael. So I can feel the train moving right now. How hard is it to prepare meals when you're in a kitchen that's rocking and rolling?
Yeah, look, man, it's pretty hard.
Like I see right here, these aren't going anywhere.
Yeah, so these are done specifically for safety and for us. So with the train rocking and rolling so much, we're really going to have shields up to protect our plates and crockery so they don't fall onto my head or reset at the back. With the stove top. We're using electricity here because it's going to be too dangerous for us to have an active gas line.
The pressure is on Chef Michael and his crew of cooks to produce fine dining meals from these cramped quarters.
We really want to showcase the environment that we're passing through or the destinations that we're arriving into or where we're leaving from. So the importance of those ingredients being good quality is very high.
Cooking on the Indian Pacific, right?
Food up. Coming out.
Our first scheduled stop is still over 500 kilometers up the line, the gold mining town of Kalgoorlie. Western Australia's gold industry exports $10 billion in gold a year and hires 20,000 people. But in the late 1800s, it was just getting started.
One of the big reasons that the railways exist in this country in the first place is because of gold. When it was discovered here, it prompted a big push for more railways to be built so that miners could get supplies and the gold could be transported all across this huge country.
So the gold rush starts in Kalgoorlie in 1893. It's absolutely massive.
Tim Moore is a Kalgoorlie local and historian who's fascinated by his town's golden past.
They're mining literally walls of gold out of the mines. So gold seams are like 4 foot wide and 8 foot thick. In 1903 was the largest production of 1.5 million ounces of gold in just 1 year.
For 20 years, intense gold fever brought thousands of people to Western Australia from around the world in the hopes of striking it rich.
The problem with Kalgoorlie, it's out in the middle of nowhere. So all you got is really goat tracks leading into this town.
To cope with the growing industry and population, the government had to build up the infrastructure.
The gold rush funds the all rail construction because they're so cashed up. The railway is literally the lifeblood. It shifts goods and services across the country.
3,000 workers risked their lives building the railway through the desert on scorching hot days with no shade and little water.
If the gold rush never happened, you wouldn't have the money to fund building the railway.
For over a century, freight and passenger trains have shared the line that was built by gold.
4,300 odd kilometres from Sydney to Perth, and there's only one track. Passing loops left, right and centre. About roughly every 60 k's two trains can pass, but other than that it's just a single track.
That means that at even the first sign of trouble on the track,
Control, 3PG1 receiving over.
Yeah, PG1, we've got Train Authority W62.
drivers start worrying about delays.
Yeah, PA8, yeah, don't quote me on it. It's just a whisper I heard due to something happening over on the desert the other side of Park.
The Traffic Control Center in Adelaide is monitoring every train on the single-track line, including us.
It's single track all the way through to Kalgoorlie, so you have these crossing locations with a main line running through and then a crossing loop to facilitate that. So we're looking to cross the trains as efficiently as we can and get them from one end to the other.
On board the Indian Pacific, traffic control is telling our driver about a cargo train derailment hundreds of kilometers up the line.
Train manager, what?
Hey, mate.
We're going to have a bit of a wait here. I think there's something going on the other side of Kalgoorlie, so we're just waiting to find out what's happening.
Yeah, roger, mate.
The disaster ahead forces our train to make an unscheduled stop, just 100 kilometers outside Perth.
We're sitting at Avon-Yard. What I know is that we have a westbound freight train, or something is amiss with that train.
As Bruce checks in with traffic control, he knows a derailment on the single-track line could have serious implications for our journey.
So what's happened, Bruce?
There's been a massive derailment up ahead of us. So we're basically here, stopped, waiting.
We've been stopped for quite a while. We weren't sure exactly what was going on, but we just now got word that a train further up the track has derailed.
Just 100 kilometers east of Perth, we're stopped at Avon-Yard Station. The derailed freight train is 700 kilometers up the line, near Kunana. The cause of the incident is unknown, but the mangled track clearly means trouble. And the temporary maintenance line is off limits for all non-essential rail traffic, including our Indian Pacific train. With a damaged track blocking the path, our only option is to head back to Perth.
No one hurt, but I mean, this kind of threw us off track in terms of our trip, right?
Yeah, it's just put us completely off the track, and we've just had to turn around and come back to where we started from. That's Perth.
This is not a common occurrence, right?
No, it's not a common occurrence.
Yeah.
I've been here 23 years, and yeah, this would be the worst one.
Nearly 2 hours later, and we're back in Perth, where 240 Sydney-bound passengers will have to scramble to make new travel plans.
Okay, you've got a lot to do.
All right, thanks, Teddy. Thanks, boys. Right.
While I wait for the line between Perth and Sydney to reopen, I'm getting a closer look at the land the Indian Pacific has to battle on every journey.
Whoa! The train is very difficult out here, and we're getting a close-up look at what it must have been like to lay the rail line here over 100 years ago. Just driving in a 4x4 here is difficult.
Wayne Roberts has been off-roading in this rugged area for over 30 years. He's an expert in the treacherous terrain on the Indian Pacific's route.
What is the land like around here? What's it comprised of? I mean, is it hard rock? Is it mud?
Look, it's hard rock and mud. You get a lot of cloud here. As you can see, we're going through a lot of clay right now.
What would have been the major difficulties they would have faced laying rail track here, especially all those years ago?
I see in this area here, for example, you've got the mud, so it'll actually be a contrast between mud, some seriously hard rock, and then you've also got the wildlife, which you would have been, amongst straight away, the kangaroo, snakes, and so on.
Not only that, the Avon River is flood-prone, so the railway was built inland and raised to keep the trains dry.
If you had a choice of building a railway line here and you didn't have to build it here, I probably wouldn't have built it here. It's kind of a bit difficult to get around on. But in saying that, the tracks have held up.
It takes a week to clear the debris from the derailment. I'm back in Perth.
Morning, how are you?
Yeah, very well, thanks.
Where Indian Pacific crews are prepping the next journey.
We're gonna give this another crack and hopefully fewer complications this time. We're ready to go to cross the desert all the way to Sydney.
Receiving, John.
Yeah, Damien, I'm just about to lock and secure car eyes door, and we should be right for a 10 o'clock departure, over.
We're back on our 4,300 kilometer journey from Perth to Sydney.
Look, they even gave me a glass of champagne to start my journey. It's a good trip already.
After an hour, we're through Avon-Yard, and the train picks up speed from 80 to 110 kilometers per hour. We're on track to reach the mining town of Kalgoorlie, 600 kilometers from Perth at 9 p.m. tonight. As guests enjoy an elegant supper, Chef Michael is struggling to keep up in his kitchen.
Just checking the Wagyu Bresaola, because we've had a little bit of an issue with the maintenance of these fridges, so the temperature wasn't looking exactly where we wanted it. The important thing at this moment in time is that don't get any high rise of temperature.
If the fridge fails, we're still 2,000 kilometers and 36 hours from Adelaide, where any spoiled food, broken parts, or even the entire carriage can be replaced. Colin Dow is the Indian Pacific's onboard train technician.
Still running, still got power there.
At 9 p.m., we arrive in Kalgoorlie. While passengers step out to explore the town's mining past,
Enjoy your evening, thank you.
Colin's top priority is solving the kitchen's refrigeration problem before we leave in 4 hours' time.
I've come under here to find where the source was coming from. That was tripping the breaker, and I've actually found it. And I believe it to be the solenoid is sticking. The solenoid actually releases the gas to keep the fridge cool, lets the gas go through. I don't have a replacement for it.
Colin cleans the solenoid and makes some adjustments.
Keep our fingers crossed that it stays working until we get back to Adelaide. It's holding at the moment, so that's the main thing.
We're back on our way. And after an overnight trip from Kalgoorlie, we'll wake up in the desolate Nullarbor Plain, where herds of animals can stop trains in their tracks. After leaving Kalgoorlie last night, we slept through a 412-kilometer ride to wake up for breakfast in Rawlinna, a tiny town 1,010 kilometers east of Perth.
Good morning, just your wake-up call.
Has been issued to train number 7 MP5 to take the crossing loop. Thank you very much.
Train driver Lance Littlewood is scheduled to pull the Indian Pacific onto Rawlinna's passing loop so freight trains can go by. Duty manager Damien Rawlings prepares for passengers to step out.
NR26, you can red light there.
Rawlinna Station used to operate as a mail outpost where trains delivered goods for farming communities.
So we're in Rawlinna, and where we are, about 12 kilometres away, is one of the largest sheep stations in Australia, and they at one time 60,000 sheep. So it's a lot of sheep shorn there.
With so many sheep spread over 1 million hectares of land, flocks are often herded using helicopters.
This is one of the first opportunities where the guests actually get out for a bit of a leg stretch. There's egg and bacon sliders.
Thanks.
Tea and coffee, and just fantastic way to just experience just a remote place.
What do you think of seeing the country from this train?
It's been quite exciting. You see a lot.
Is you get to stay in the same hotel more than one night.
Yeah.
And the fact that everything is done for you, and the train is especially delightful for that kind of experience.
Yeah.
Another 3 metres NR26.
It's okay, Brett. Yeah, we've departed Rawlinna at 0803.
From Rawlinna, Lance Littlewood and his driving partner, Cole Seaton, will take us almost 500 kilometers to the town of Cook. Combined, Lance and Cole have been driving trains for more than half a century and have crossed Australia thousands of times.
One of the challenges of the job is the fatigue angle. It's not for everybody.
Because it's a 12-hour shift, between here, Cook and Kalgoorlie, you've got to have a 2-man crew. So 12 hours, we'll work roughly quarter each. Some bloke's been working out here for over 30 years. Done the same trip through here. It's a great job. I love what I do. It's, probably till I retire.
They're taking us across the desolate Nullarbor Plain, a flat, treeless desert 1,100 kilometers from west to east. The Nullarbor boasts the longest straight stretch of railway track on Earth at 478 kilometers long.
Got one curve all the way to Cook.
Here, the Indian Pacific hits its top speed of 115 kilometers an hour, and drivers need to stay alert. The last place you want to have an accident is hundreds of kilometers from help.
That's right. If you come off, we come off here, we're stuck. We're stuck off here for 12 hours. That's the worst thing. Derailments.
One major cause of derailments are the herds of wild animals and livestock that cross the tracks in the middle of nowhere.
Go over, you pig bastard. I was just waiting for that big one to get across. It didn't really want it to go. Got cows, kangaroos, emus, mainly the camels. If you hit one of them, you can do damage to the front. Camels are heavy, they'll smash your windscreen, derail, lift up carriages. They're a real problem for you.
Another problem for trains at top speed are damaged tracks. Up the line beyond the Nullarbor,
There we go. They can be, if we don't keep a watch out, they cross in front of you.
teams of track technicians travel across hundreds of kilometers of railway every day. They're visually inspecting the rails for cracks, chips, and kinks.
If we're driving along a straight like this, and you can see like a snake in the track, and if it's not safe, we'll have to get out, get an excavator out here, line it, tamp it, make sure it's all safe before we let a train pass over it.
As you can see, the defect's there. It's got a crack down through the rail. It needs to be replaced.
The damaged tracks are reported before maintenance crews are dispatched.
The machine you see here is a tamper. As you can see, it's lifting the track, it's lining the track from side to side, and it's packing the ballast underneath the sleepers.
Technician James Croak specializes in track leveling and realignment. The tamping machine has a sidekick that keeps it in line.
Well, what we've got here, this is our laser gun. It's held in place by the cradle. It's as simple as sighting in the laser to the laser receiver on the machine.
From 400 meters up the track, the laser is beamed from the trolley onto a receiver at the front of the tamping machine. The machine locks onto the laser beam and follows it as a guide for how high to lift the tracks, bringing them to proper alignment.
Yeah, the machine's locked into the laser beam there, and it's going to pull 400 metres of track perfectly straight. This machine's capable of about 700 metres an hour, and this machine does the work that used to take 100 men.
After fulfilling train authority W42, proceed to cook.
By 11 a.m., the temperature outside is already over 40 degrees Celsius. In this heat, a power or air conditioning failure could make life on board the train unbearable, or even deadly.
Air conditioning causes the most power when we go through the Nullarbor.
The Indian Pacific's onboard technician, Colin Dow, keeps close tabs on both power vans. Each van runs 3 108-kilowatt generators. Combined, they produce enough electricity to run 22 houses.
It's very vital that they run 100%, so it supplies power to most of the carriages on this train. I check the oil every day, and this is good at the moment. It's at the right level.
Well, up ahead after here is forest. There's no shops at forest, so we'll have to stop and unload it on the south side.
Forest is just a small airstrip, the train station, and a bed and breakfast, all run by the town's 2 permanent residents. For Ilsa Jones and Lee Gilmore, the closest supermarket is a 1,100-kilometer round trip.
Hey guys, how are you?
I'm Lee.
Good, Teddy.
Hello, Ilsa.
Great to meet you. So this is Forest.
Yes, it is. Yeah. We're almost halfway across Australia now, in the middle of the Nullarbor.
And you two are the only residents of Forest, right?
That's right.
Yeah, full time.
Yep.
Yeah.
Population 2.
Population 2. What's the delivery that they're going to offload today?
There's some chemist stuff. There's the mailbag, obviously.
Yeah, there's beer too, right?
Yeah.
Is the Indian Pacific the only way that you get the type of stuff you're getting today?
Yes.
Yeah, it is. It's our lifeline, basically, to all the supplies that we need at Forest.
Yeah,
you know.
if we were cut off from here, you know, then we couldn't run the business, you couldn't run the accommodation. It'd be hard to get all the necessary supplies to repair stuff, so the Indian Pacific's that.
All right, well, we got to get back on the train.
Lovely to meet you.
Yeah,
Been
you
a pleasure.
too. Yeah, you
Have
too.
a good one.
Not too many flies.
How's it going? Hey, good yourself. How you going? Here's a little light one.
Yeah, nice wet one.
All right then, we'll see you next time.
Yeah, cheers.
Have a good one. Cheers. See ya.
From here until our next stop in Cook, it's 300 kilometers with no bend in sight. For drivers Lance and Cole, it's lunchtime.
If we feel the need to cook our own food, we have a hot plate, a fridge to store our food, and a fry pan to cook our food on.
For security purposes, the driver's cab is locked down, so there's no access to the train's master chefs.
How would you like your gammon done, Spider? Medium? Culinary delight.
Before Cole can dig in, the train stops for another isolated mail drop.
Sorry, that's everything.
Everything?
That's it.
And a shift change for the drivers.
Lance is the lucky one. He gets to eat my cooking.
Looks very tasty, Cole. You've done a very good job.
No criticism accepted.
There's lunch. Lovely. Oh, that was nice. Now I just got to do the dishes.
Oh, do you?
That's all right.
No such thing as a free lunch.
Not true.
As we race across the Nullarbor, maintenance crews up the line are battling temperatures above 40 degrees Celsius.
Extreme hot weather can get up to 47, 48, which can cause the buckle of the line.
Buckled tracks derail trains, so the team fights the heat with fire.
Just to stop derailments from happening.
More than 1,500 kilometers from Perth, we're approaching the town of Cook, the only scheduled stop across the Nullarbor Plain.
Cook is an essential stop. Take on fuel. Without the fuel, obviously, there wouldn't be enough to get to Port Augusta.
Cook was established as an important rest stop for trains and their passengers. But when the railway changed ownership in 1997, the new owners cut operating costs. Except for vital train services like fuel and water, Cook was shut down. Today, it's a ghost town with a population of 4.
Look at that. It says if you're crook, come to Cook. And crook is actually Australian slang for sick. And it says that because there used to be a big hospital here when this was a thriving area, when it used to be known as Queen City of the Nullarbor. Not today.
After nearly 1,100 kilometers through the scorching heat, Colin, the train tech, gives the Indian Pacific some serious attention.
Looking for the bearing housing temperatures. See what the temperature is, 47 degrees at the moment, but that can lead to possible overheating and it can seize up and cause derailments as well. Yeah, we're looking pretty good at the moment.
At the same time, every water tank is refilled. Once full, the Indian Pacific carries 22 tons of water.
All the wagons will be watered, and we've also taken water on here on the loco.
Every week, 120,000 liters of fresh water is shipped into Cook by cargo train and stored in silos ready for the Indian Pacific. Finally, the 12,500-liter fuel tank gets topped up.
So I'm putting another 6,000, and that'll get us all the way through to Sydney.
Train manager, train tech Cole, you're receiving, over.
Receiving, over.
Done the wheel bearing inspection and everything's ready to go, over.
Roger, receive that.
From Cook, we're traveling through the night. It's over 15 hours and 1,100 kilometers to Adelaide.
Look at this, the landscape outside has changed dramatically. Look at that, as it opens up, you can see all that green, all those trees. That's because we've come through the Nullarbor Plain now.
We're out of the desert, but temperatures still routinely hit close to 50 degrees Celsius. Up the line, maintenance crews are battling the outback heat.
Get ready. Righto.
Out here, temperature swings expand and contract the rails, causing buckling and cracks in the track. To fill those cracks, the crew uses a technique called continuously welded rail, or CWR.
That involves taking joints out of the track and continuously welding it out. We'll have the molten steel, which is in your pot. This is your molten steel, which will drop into your moulds. So they're preparing that mould. Your pot sits on top, your molten steel drops down in it. It'll mould onto your steel, your rail, and that'll hold it.
With every joint the maintenance crew eliminates, the railway becomes stronger and trains can go faster.
Right, so at the moment, this track speed's 35 k's an hour, and once we finish CW and adjust it and weld it all out, the track will be up to 60 k's an hour, so that's a big increase. The increase is efficiency and it's good for everyone.
Day 3 on the Indian Pacific begins 2,700 kilometers east of Perth, with an early morning arrival in the city of Adelaide. Passengers can step off to grab breakfast in the city, while the Indian Pacific gets its most dramatic overhaul of the trip.
Wayne, who's at the back? Joker, where are you up to?
Adelaide's station warehouse manager, Tony Wall, has been getting ready since dawn.
With the Indian Pacific, it is only a 3-hour turnaround today. Totally got the ticking clock going in the back of the head.
Tony's stocking the train with enough food, drinks, and supplies to get the Indian Pacific to Sydney, then back to Adelaide.
This will be the whole lot. This will be all the food, linen that'll be exchanged throughout the journey. Everything emanates from Adelaide.
While Tony's team provisions the train, Colin checks on the refrigeration system.
It's actually working now at 2.5 degrees.
Then the train gets split in half.
Driver of the Indian Pacific, you're receiving operations.
And both halves are sent to the Adelaide Maintenance Centre for a scrub.
We wash it every week, but the appearance on the outside is crucial for our guests. But just as important, we have a number of components underneath the train, which is vitally important also to get clean.
Untreated dirt buildup prevents the components from working at 100% and can add thousands of kilograms in unnecessary weight.
So it's gleaming in the sun now. It's almost ready for departure.
With the sparkling train back at the platform, the final items are loaded. And a familiar face takes control as train manager.
Ladies and gentlemen, we need to board the train, folks. Thank you, folks. Teddy, how are you, mate?
Good to see you again, man.
Good. Listen, I'm going to make sure we get to where we're going this time, mate.
We've already gotten a lot further than last time. I'm glad you're back with us, though, man.
I'm glad to see you, mate. All aboard, folks! All aboard! Thank you. Let's be having you, gentlemen.
Ladies and gentlemen, all passengers on platform 1, please stand well clear behind the yellow line.
Before leaving Adelaide, a second locomotive was added to provide extra horsepower. We'll need it for tomorrow's climb up the Blue Mountains.
After Adelaide, the Indian Pacific's headed into the most remote part of our journey, where there are no roads, no maintenance facilities, and no help if anything goes wrong.
Before we reach our destination, we have to pass through drought-ravaged bushlands that can become tinder in Australia's hot, dry summers. From Adelaide, we're rolling towards Broken Hill Station in the state of New South Wales. Broken Hill's our final stop of the day, where the Indian Pacific takes on its last load of water.
7:30, we'll take it out and head off to Sydney, mate. Easy as.
From here, it's a 1,000-kilometer overnight ride until we reach the Blue Mountains. The highest peak in the Blue Mountains is nearly 1,200 meters above sea level.
Okay, yeah, this is probably part of the steepest plate through the Blue Mountains. Can play havoc in the wet with the locos.
10 kilometers from here, tourists can experience that steepness up close.
The Blue Mountains are the site of numerous cliffs, canyons, waterfalls, and caves spread over 1 million hectares. They're also home to the steepest railway in the world.
This 310-meter-long incline railway started as a trolley for miners to haul coal up the canyon's sharp cliffs. Now it's a scenic attraction run by third-generation owner Anthea Hammond.
The miners never earned much money, so they used to charge the tourists 6p one way back up in the train. Initially, they actually just used the coal skips and lined them with hessian sacks, so they'd pop the tourists in the coal skip and pull them up.
70 years later, 3 carriages carry 84 passengers, so they don't have to climb 1,000 stairs.
All right, here we go.
Yeah, ready to go. Make sure you're holding on.
It is very steep.
Keeping the 15-ton train steady as it drops 200 vertical meters takes some serious muscle.
This is our winch system. We have 2 haul ropes on the winch system itself. Each one of those haul ropes has a braking strain of 57 tons. One rope is more than enough, but we've got the 2 there just in case.
Whoa, is this the steepest part right here?
Yeah, so this is the steepest part we're on now, 52 degrees.
Woo! When tourists take this train, are they really surprised at how steep it is?
They have the face you did.
This is awesome. And there's the valley. What a view. It's amazing to get here on a train, too. Wow, that incline is really something.
Back on the Indian Pacific, we're rolling through the eucalyptus forests that define the Blue Mountains. Eucalyptus tree oil vaporizes, becoming the blue haze that sits above the canopy. The oil and fumes are both extremely flammable.
In addition to the extreme heat, flooding, and wildlife on the tracks, another hurdle the Indian Pacific faces is the constant threat of brush fires.
During hot, dry summers, eucalyptus tree oils can turn the forests into a tinderbox.
I got pretty close to him a couple of times over the years. You can smell the smoke in the train. Once we had to stop to let the bushfire get out of our road before we could go forward. We've stopped for about 4 hours, stand back, let it go, and then once it's clear, and it clears pretty quick, we go through.
By Valley Heights Station, we're entering our final 50-kilometer stretch towards Sydney Central Station.
Let me know if you're going to be 10 minutes early and I'm sort of only halfway where I need to be.
Yeah, sure are, mate.
We're almost in Sydney, but the hard work isn't done yet. The train platform in Sydney actually isn't long enough to fit the entire length of the Indian Pacific. So train staff have to split the train in half.
The whole train stops 50 meters from the station. The lead locomotive is decoupled from the train, while the secondary locomotive pulls the front 14 carriages to the platform. Then the lead locomotive can back up to pull the rest of the train to a platform nearby. The whole operation takes 40 minutes.
All our guests are off. They've gone Perth to Sydney, but we'll turn it around in a couple of hours' time, take it back to Perth again. Mate, I love trains. I love the journey. I love the guests. I love the trip.
That was an amazing trip through the outback and across this massive, vast country. I'll never forget seeing Australia on the Indian Pacific. Norway is not only famous for Vikings, it also includes some of the most incredible train journeys on Earth.
But spectacular scenery can be deadly.
Blocks of rock fell down from the mountain and hit the railroad.
Staying on track means moving mountains.
My favorite part of the job is to blow stuff up.
This rare, epic adventure takes me way up north.
You're crossing a line to another world, the Arctic world.
Join me as we ride across the unforgiving terrain of Norway's Bergen Railway and Nordland Line. The Kingdom of Norway boasts not one, but two of the most spectacular train journeys in the world.
You will see the glaciers, you will see the fjords, then you really feel that you're climbing up to the mountains.
I'll jump on the Nordland Line to head north from Trondheim to Buda. But first, the Bergen Line, or Bergensbanen, begins in Norway's capital, Oslo, traveling across the country to the west coast city of Bergen. This trip from Oslo to Bergen has lots of beautiful landscapes and fjords for tourists to take in. But before our train can make the trip, maintenance crews here in Oslo have a ton of work to do. 3 times a year, Bergen Line mechanics give their locomotives a comprehensive tune-up. They don't just look under the 5.5-ton hood, they take the whole thing off.
That gives us access to all the components. For example, the compressor, the fan, the firefighting equipment. I've been working here for 10 years, and we work with everything from electrical work to mechanical work, changing parts. You learn something new every day.
On the other side of the maintenance depot, mechanics prepare to lift an 88-ton passenger carriage so they can examine its wheel sets, called bogies.
Comes up, yes. We have to take it out on this side.
They've spotted a problem with the bogie's pillows, hollow rubber discs that act as shock absorbers.
This pillow here is old and it's maybe not holding the air, so we can have leakage when we're putting together.
Flat pillows can mean more than a rough ride. They can make the carriage unstable.
Pillows, they have to be 100%, so we're just replacing it to be sure that it's not be an air leak later.
Only after a locomotive is declared fit for duty can it return to the tracks of Oslo Central Station. Where Chief Conductor Ode Henrik is responsible for the train being ready to cross the mountains.
It's a little bit walking. The train is 244 meters long.
The locomotive leading the charge is the electrically powered EL-18. It's 4.3 meters tall, 3 meters wide, and 18.5 meters long. The loco draws power from an overhead line through its pantograph to drive the motor and deliver over 7,300 horsepower. That's enough to pull a maximum payload of 2,040 tons, the weight of more than 1,100 passenger cars. Once Ode is satisfied with the exterior, he joins engineer Stian Usletten for the final check.
We are checking the brakes. Over the mountains must be a good brakes.
When the equivalent of 1,100 cars need to stop fast, good brakes are critical.
I use pneumatic brake for the whole train. I just put it towards me, like that.
Pneumatic brakes let the driver quickly stop the whole train. When he needs to stop faster, there's a second option.
If I need some more brake then I can use the electrical brake only for locomotive.
Electromagnetic brakes are strictly for emergency stops. These are sets of steel bars fixed between the wheels. The steel bars drop to the track and are magnetized by an electric current. The supermagnetic bars then grip the tracks, holding the locomotive firmly in place.
If I don't use the brake for the whole train and only for the locomotive, you will get a little ding like that in the wagons, you know?
My bag's packed, I've got my ticket, and I'm ready to grab a seat for what I'm told is one awesome journey.
Please observe that this is train to Bergen. Departure time from Oslo Central, 8:25.
Our nearly 500-kilometer trek begins in Oslo. The train runs through farm country to Hønefoss, then into the Hallingdal Valley. From there, we pass Hardangervidda National Park, with a stop in Finse. Then the train heads through the Rondelen Valley and along the edge of a fjord before reaching Bergen after 7 hours. It doesn't take long for our train to reach the first of the Bergen Line's most defining features.
So we're about to go into a tunnel, and it's incredible because on this Bergen line, there's actually 182 of them, and they stretch over a length of 73 kilometers. And to put that into perspective, if you stacked all those tunnels on top of each other, it would equal 8.5 times the height of Mount Everest.
But the rail network's single-track tunnels can be a bottleneck for trains. So Norway's rail system is constantly upgrading its capacity. 10 kilometers south of Oslo, the town of Østland is the site of the $3 billion Follo tunnel project. When it opens, the tunnel will have dual tracks, allowing two-way traffic or express service. They're digging deep to create what will be the longest railway tunnel in the country.
And just now, we are inside, in front of the 4 tunnel boring machines.
The tunnel boring machine, or TBM for short, is a massive multitasker. A round cutter head munches through rock at 2 revolutions per minute, using dozens of steel cutters. Excavated material is moved out on a conveyor belt, while hydraulic cylinders push the TBM forward.
If we have a very good day, we may excavate nearly 30 meters of tunnel during one day.
The TBM doesn't just bore a hole, it builds the tunnel as it goes. Its hydraulic arms lift and bolt concrete support rings into place. Each ring weighs almost 8 tons. The rings resist the massive weight above while keeping out the moisture below.
And altogether, we will install 20,000 rings for this tunnel project.
But even rock-chewing behemoths are not immune to the daily grind of Norwegian bedrock.
They are changing cutters, and they are every day fighting against these extreme hard rock conditions.
Up to 20 cutters are replaced each day.
Many will say that this is extreme hard rock conditions, but that's how it is when we are tunneling in Norway. We are used to it.
There's no room for surprises when you're deep underground. Geologists and their probes are way ahead of the TBMs.
We do a lot of investigations beforehand, so we know more or less where these weakness zones and so on going to be. So we have this estimated already, so we can be prepared.
Construction started in 2015, and the high-speed rail tunnel is expected to open in December 2021. By 2030, it's estimated that Norway will spend nearly $20 billion to modernize all 4,000 kilometers of its rail network.
The Follo project is the largest infrastructure project under construction in Norway today, and it's a fantastic project.
Outside Oslo, we pick up speed to 160 kilometers an hour. Back in the 1870s, this jagged terrain presented a nearly overwhelming obstacle to anyone plotting a path.
When surveyors were given the job of building a railway between Oslo and Bergen, just finding a passable route was an unbelievable task. And before it was built, 11 other paths were considered, but all of them were deemed too dangerous to build on.
The epic construction of the Bergen Line has captured the imagination of historian and author Jan Helge Østland for years.
You've written a book on this railway. When you were researching it, what surprised you the most to learn about this line?
The construction workers and the period and all the challenges they had to build this railway. It was terrible condition for the workers. They had bad food, bad weather, everything was against them. But they did the job.
Construction officially began in 1889, after 3 decades of planning. Workers from Norway and all over Europe used hand tools like pickaxes, shovels, and dynamite to force their way through mountains and hard rock. The Bergen Line officially opened in November 1909, after nearly 20 years of treacherous work.
The construction workers was called Ralla, and there was thousands of them building the line. And not every one of them survived.
With Oslo 90 kilometers behind us, the scenery takes a distinctly alpine turn. And the uneven cliffs in the distance are an omen of the potentially lethal conditions ahead.
In 1971, a huge block of rock fell down from the spot where we're standing now and hit the road and the railroad and swept it out in the fjord.
I'm traveling across Norway on the spectacular Bergen Railway.
Why would you tell someone that they have to take this rail journey?
Because you have all that exciting contrast. You will see the glaciers, the fjords. It's amazing. It's the best line we can offer you.
As we enter the Hallingdal Valley, you see why Norway is called the Stone Country.
One of the many amazing things about Norway is that more than 50% of the surface area of the land here is made up of mountains. So that gives you a sense of how difficult it is to build railways here through all that stone. It's really amazing.
And difficult to maintain. Those picturesque peaks can cause serious damage. Mountains and cliffs that make the Bergen Line so spectacular also make it dangerous. Geologist Trina Hellesimenis is looking for trouble spots.
We're now going up to the top of the mountain. There's a very huge rock below us that we're afraid to come down and hit railroad and road.
Trina and her crew touch down 600 meters up Bjornafjellet, or Bear Mountain. 350 kilometers west of Oslo, it looms over the Bergensbanen track, waiting to strike again.
In 1971, blocks of rock fell down from the mountain right here where we're standing and hit the road and the railroad and swept it out in the fjord.
Fortunately, no trains were passing when an estimated 145 tons of rock fell, demolishing a 150-meter-long section of track and dumping it into the fjord below. To warn against future catastrophe, Trina uses a laser-guided prism system to detect any movement on the rock face.
This is a prism. We're drilling this small thing into the rock, and it works like a mirror.
Once the prisms are drilled into the mountain, a laser is beamed from a station 1 kilometer away to record the prism's precise coordinates. Geology teams check the prisms a few times a year, looking for movement. If the prism's coordinates have changed, it means the rock may have become loose and could be ready to fall.
Tell me if you see rocks with big fractures behind or other dangerous stuff.
We will take a lot of pictures of it. I've only got 2 prisms on the other loose rock.
Once in position, they drill holes into the rock face so they can screw the prism into place.
The work we're doing up here is very important work. If we see that the rocks move, then we need to take preventive action. That could be put up a rockfall fence at the base of the slope so that the rocks cannot hit the travelers.
It's impossible to prevent every kind of debris hazard, which is why the driver's cab is like a fortress on rails.
The front window is reinforced, so if a stone is 1 kilo and it can hit the front window in 360 kilometers per hour and not go through.
Driver Stian is nearing the end of his shift. A new driver takes over at Ål Station for the most grueling part of the upcoming journey.
Så, god fornøyelse. Jo, ha det.
From Ål Station, the train begins the climb into the Hardangervidda mountain range, where rocky terrain and steep inclines place a unique strain on a locomotive's wheels. Which is why the Bergen Line maintains a specialized wheel maintenance center in Oslo. Mechanic Arne Nielsen ensures every wheel sticks tight to the track.
We fix wheels for them, and any other parts they need fixed.
The Norwegian railway system has trusted this lathing machine to keep its train wheels pristine for 3 decades.
What's special about this machine is that there's one, maybe 2 operational ones in Norway. This is an elderly lady from 1985, and she demands to be treated with respect.
Using pre-programmed measurements, the lathe shaves material from the wheels to make them uniformly round.
This is like a photocopier, and it follows whatever profile we program it to.
The wheels are heated to make the metal easier to shape, but not so hot that they warp.
Now, I'm removing the shavings that have come off the wheel. This stuff is about 300 or 400 degrees Celsius, so it's a good idea to avoid it.
Just one cracked or warped wheel can cause an incident. Regular maintenance keeps the wheels turning smoothly.
It's alpha and omega, simply put. If the train doesn't have wheels, you can't drive it, you know?
Falling rock and steep mountainous terrain aren't the Bergen Railway's only challenges. The line's wooden sheds protect against snow buildup, but are vulnerable to fire. And on isolated stretches of track, passengers are at risk. I'm discovering Norway on the legendary Bergen Railway. 240 kilometers west of Oslo, we're climbing into the Hardangervidda Mountains toward Finse Station. On the outskirts of Geilo, the green ski hills show why the Bergen Railway is just as popular in the winter.
A lot of tourists take this train. People come from all over the world, but do you find a lot of Norwegians take it as well?
Yes, especially in the holidays during winter, because, you know, Norwegians love skiing.
Right,
yeah.
The snow is good for skiers, but it can be a disaster for trains. Up here, the winter can last for 7 months. 1.5 meter high snowbanks are common and can stop a train in its tracks. Like a covered bridge, snow sheds shield the most exposed stretches of track.
Snow sheds were built to protect the tracks. We're actually going through one right now, but one of the major problems is a lot of the sheds are made of wood, so they're really easily destroyed by fire.
In June 2011, it's believed that sparks from a welding accident set fire to a snow shed near Finse. A Bergen Railway train was trapped inside. The train was evacuated and nobody was hurt, but the shed and the train were consumed by the flames. With 170 wooden snow sheds along 13 kilometers of track, there's a major push to replace them before another fire threatens lives on the line.
We don't want the high risk of fire. So with the steel construction, we take that risk away.
This new 65-meter-long shed uses 305 structural steel beams with steel plates for the walls and roof. Each beam weighs nearly 1,000 kilograms and must be trucked in from Oslo. Because the site is perched on a cliff in a remote area, it's risky business for the workers.
We have to deal with the nature around us. The rocks above us have to be secure.
Carl turns to the expert guidance of geologist Trina Hellesimenes.
These are challenging conditions because the cliffs are very steep. There's a lot of fractures, making blocks that could easily fall down and damage the railway. We have rocks with very different properties. Lower down in the valley we have soft philitic rocks, and here we have very hard gneiss. It's a hard rock with a lot of fractures. These rocks are so hard and sharp that even a small fragment can make a lot of damage.
Another challenge is Norway's epic winters, which limit construction to just 5 months a year.
On the Bergen line, we have now replaced 700 meters with steel construction.
Replacing all 13 kilometers worth of Bergen Railway sheds will take nearly 40 years.
We're a good ways into our journey now, and you can tell the landscape and the terrain has changed drastically. Now we're approaching Finse, which is the highest station on the entire line. It's actually the highest elevation station north of the Alps, and I'm told that it's really, really beautiful, and already you can see the scenery is just breathtaking.
In winter, the exposed plateau gets hammered with snow. So the track west of Finse has been covered by a tunnel to cut down delays.
Soon we're coming up to the Finse Tunnel. It's a major feat of engineering. It was built in the 1990s, and at over 10 kilometers long, it's the longest tunnel on the entire line. And the opening to the tunnel is really narrow. There's only about a meter of clearance on either side of the train.
Like so much of the Bergen Railway, the Finse Tunnel is a single track.
Slowing down.
Which means when the train in front of us gets stuck inside, there's no way we can pass.
There's a freight train in front of us, which have some problems, so we have to wait here a few minutes before we can go further up.
So what happens now with our train?
Oh, we have to stay and wait. We are in the middle of nowhere.
This is Finse Station. We're over 1,200 meters above sea level right now. Well, also very, very remote up here. There's no road access to this area.
That freight train you see is blocking our line, so we can't go further on.
So all 440 passengers on board are stranded until they can unblock the tunnel. The Bergen Railway's Finse Station is more than 1,200 meters above sea level in Norway's Hardangervidda Mountains. We're stopped here because the freight train in front of us lost momentum when climbing the mountain. Now it's stuck in the Finse Tunnel, waiting to be rescued.
Vi har tatt av kameraet foran så.
Norway's rail traffic controllers, like Bjorn Jalumstra in the Oslo Center, are trained for exactly this type of emergency.
It's not often that we have a freight train stuck in the tunnel, but it can happen.
Custom track view software has mapped every detail of Norway's rail network from the train driver's perspective.
In this situation is to have the help from the Finse side. If we have a train steer, we will use them to help the freight train to get out of the tunnel.
Our team in Finse gets their orders.
We have a plan. Our train is going to pull that train that way.
Our EL-18 locomotive and all 8 passenger cars will pull the 1,000-ton freight train out of the Finse Tunnel, deliver it to the station's sideline, then we'll pass beside the freight train to continue our journey.
Yes, they're coming. You have to come on board. Come in.
Well, I'm almost the last passenger to get back on, and we gotta go quickly.
Inside the snow shed, engineers couple the trains.
We've pulled the freight train back, and we're going to deposit it on a parallel line right beside us here. Thankfully, though, we have this siding here, and that's what's going to save us today.
Our journey is underway again, but this delay will affect dozens of passengers' travel plans.
When we left the Finse station, the train is now 1 hour and 40 minutes delayed. We are getting information from Norway. Okay. Maybe they will have a new ferry for you.
So you've got a bit of a travel delay, right? What's happening?
We were hoping to go along the fjord on the boat. The problem is that there is only one boat left today, and we hope that we will be able to catch it.
We will arrive at Myrdal in about 5 to 6 minutes.
At Myrdal Station, some of our passengers will hop on the train to the village of Flam, where they'll board ferries and cruise ships that glide through Norway's fjords. Luckily for passengers heading to the fjords, we arrive in time for them to catch their train. Myrdal Station is 336 kilometers west of Oslo, and the Flam railway branch runs north of the Bergen Line. The 20-kilometer trip descends 866 meters to sea level at Flåm. The Flåm line began construction in 1924 to open up the Flåm Valley, one of Norway's hidden treasures. It's easy to see why it was so well hidden. The track is short but steep. It's a feat of railway engineering. Bengt Hammer specializes in the history of the Flåm line.
I know the descent from Myrdal down to Flåm is quite steep for a train, isn't it?
Yes, before they decided to build the line as a normal gauge railway, they had long discussions in the parliament and by the engineers. So they sent many to study the Swiss railways.
Switzerland's Glacier Express uses a cog and chain system to pull itself up the steep slopes of the Swiss Alps. As a standard gauge line, the Flåm Railway is built to gradually travel the 20 kilometers to and from Flåm, so no extra mechanical devices are needed.
Here on the Flåm Railway, there are several waterfalls, but they're not just part of the scenery. They also help power the train.
The Kiosfossen Falls are one of the line's first stops. The cascade runs through a 2-generator power plant beside the falls, creating enough electricity to power the Flåm line, Flåm Village, and the Bergen Line Railway.
Wow, look at that. It's the most spectacular waterfall on the line. And spectacular doesn't even do it justice. Incredible.
After the Kiosfossen Falls, the train crisscrosses down the Flåm Valley.
The scenery is incredible. It's hard to imagine that they built this so many years ago using hand tools. It boggles the mind.
In Flåm, travelers can either extend their trip out on the fjords or head back up to Myrdal to continue their scenic journey by rail. Back on the Bergen Railway, I'm on the final leg of my westbound journey, but we're in for one more travel surprise.
We have some traffic information. When we come to Voss, this train is cancelled between Voss and Bergen.
After pulling the 1,000-ton freight train, our EL-18 locomotive must head back to Oslo for an immediate inspection.
So at Voss, our last big stop before Bergen, we're going to switch trains to a new train.
Yeah, that's why.
So this is a lot of logistics for you to work out.
Yes, it's a weird.
Ode has spent 38 years working on the Bergen Railway. His passengers are in good hands. As we pull into Voss station, there's a brand new commuter train that's been brought into service 1 week ahead of schedule, just to keep me and my fellow Bergen-bound passengers on time.
This is Bergen? Yes, it is. Yes, this is a train to Bergen. There is no reservation, so you can take and sit anywhere.
So now we're jumping on our new train here in Voss. This is now going to take us to Bergen. Not part of the original plan, but part of the adventure.
From Voss station, we'll roll through Stanghelle and past Bear Mountain. Then we'll hug the Sur Fjord before our final 15-kilometer stretch into Bergen.
Hey, so this is your new office on the new train, right?
Yes, it is.
The final 100-kilometer stretch from Voss to Bergen takes us through the western fjords that define Norway.
This is one of the fjords in Norway. The other side is called Osterøy.
It's a truly awesome end to the first leg of my amazing journey.
Well, we made it to Bergen. A little late, but what an adventure, and we're not done yet. Next up, we're headed on an epic journey from Trondheim to Bodo on the Nordland Line.
The city of Trondheim is 629 kilometers north of Bergen. It's called the Viking capital of the world, and it's where my rugged trip north begins. It's 5:30 a.m. at Trondheim station. And time to fire up the Nordland Line's diesel locomotive. It's one of the few engines that reliably runs on this line into the Arctic Circle.
It sounds like American Yeah, it's a GM diesel.
That rumble is a magical sound for Einar Ulriksson, who's worked on this line for 4 decades.
Yeah, it's a muscle car.
The Nordland locomotive, known as the NSB Die 4, measures 4.34 meters high, 3.17 meters wide, and 20.8 meters long. The Die 4 locomotive has nearly 3,300 horsepower and pulls 5 passenger cars. That includes a cafe car in the middle and a family car near the back. Chief conductor Inga Becken checks the passenger cars before they're coupled.
I've seen on every wheel, looking down to see something wheel who is damaged or something.
The train is set for our journey into one of the most rugged landscapes in the railway world.
I'm going to drive for 5.5 hours. What makes this line different is all the unmarked crossings. You have to pay attention. You have to be prepared to stop the train immediately.
The Nordland line spans 729 kilometers from Trondheim to Buda, and it's one of the few railways on Earth that crosses the Arctic Circle. It's also built across incredibly difficult terrain that required 293 bridges and 154 tunnels.
The Nordland line departs Trondheim by hugging the shore of the Trondheims Fjord. At Steinkjer station, we'll veer inland through the town of Mosjøen before journeying way north into the Arctic Circle and past Saltfjella, or Salt Mountain. We'll head west at Fauske along the Kjørstad Fjord to our final destination of Buda.
And it seems like we're kind of getting out of civilization now. We're getting into a rural area.
Yeah, you see it's a farming land, people living here, but it's a long distance to the next town.
That remoteness can leave trains vulnerable to the destructive forces of Mother Nature. So maintenance crews fight back with some destructive forces of their own.
Dynamite actually always wins. It crushes everything.
I'm rolling north on Norway's spectacular Nordland line. We've followed the Trondheims Fjord through tunnels and over bridges to the depths of hell.
One of the biggest engineering difficulties of the Nordland line came from the hundreds of bridges that needed to be built. And now, over a century after construction first began on the line, keeping the bridges standing is an ongoing battle.
Good looking, Stefano.
This is a section of the original Hell Bridge. It was replaced in 2016 by a modern double-track structure.
This bridge was on the original Nordlandsbanen. It was put into service in 1902, but a lot of the details of this bridge are identical or very similar to the details of bridges in service.
This antique section now has a second life as a structural test lab near Hell Station. It allows engineers like Gunstein to get a unique look at how Norway's old bridges are aging.
There's a sensor in the tip of this sledgehammer. It's read by the computer.
Researchers start with a hammer test to figure out where the bridge might be most vulnerable.
When I hit the bridge here, we see readout on this computer the impact from the hammer.
Sensors are placed on 2 identical bridge components. The hammer hits a point connected to both parts, causing vibrations. The sensors read the vibrations' frequencies to determine which points on the bridge are structurally sound and which parts are in need of repair.
And if signal from the sensors are different, then we suspect that there is a damage in one of the joints on either side of the bridge.
To stimulate the stress load of trains crossing the bridge, they use a shaker test, where sensors read the bridge's total structural integrity.
We've found some severe damages that have not been found in the regular inspection scheme, but that just shows that the work we're doing here is important and producing results.
This old bridge helps extend the working life of Norway's rail infrastructure. 180 kilometers into our journey, and the farmland of the Midland region gives way to the forests of the Nordland. Several of the line's 44 stops are by request only and seem to be in the middle of nowhere. In remote locations, the rail crews need to look out for each other's needs.
This was a call from another train. We're gonna meet in Lassemon, and they wonder if you have some coffee for them, for the crew. I get a green light, and I have to leave them the coffee on the platform, take it on myself.
"300 kilometers ahead on the line. These workers have something stronger than caffeine to perk up their day.
Heavy fire. My favorite part of the job is getting paid to blow stuff up.
Here, a section of track runs along a rock face that's dangerously close to crumbling into the river below. Tommy Carlson and his explosives team are preparing a new rail bed on firmer ground. They need to remove 20 meters of cliff to do it.
Today we are blasting around 350 cubic meters rocks.
They have to blast away an entire rock face without damaging the tracks, then clean it up before my train passes.
The train is coming in around 2 hours, so they need at least 1 hour to clean the tracks.
They're using 200 kilos of explosives to blast a 50-ton section of the cliff. But they can't afford to blow this job by rushing.
We have a lot of danger with this job. The height's 14 meters down, and of course you got all the dynamite. Dynamite actually always wins. It crushes everything. Therefore you have to be careful with it.
Once the dynamite's in place, the crew fills the blast holes with heavy gravel. The extra weight directs the dynamite's energy into the rock face.
Then we can control it a little bit, not go straight down the river.
1,300 kilo mats made from old truck tires and thick steel wire keep rockfall off the track and control the blast.
We don't want the rocks to fly up in the air. We want them to stay in this area. We're gonna blast now. Koppla på. Okay. Yeah, then we fire. The blast went perfect. When the blast goes off, you can feel the vibrations in the mountains and in the ground. It's a good feeling.
1 hour later, all the rubble is cleared, just in time for my train to pass. We're in the heart of the Nordland and approaching the historic town of Mosjøen.
So we've stopped at Mosjøen Station, and the next stretch of this line has a really troubled history. The tracks themselves were laid by prisoners of war who were forced to complete this section of the railroad by Nazi forces in World War II.
12,000 Soviet prisoners built 140 kilometers of track north, deep into the Arctic. It's a stretch of track that reveals a history many in Norway are ashamed to admit.
Because the Norwegians collaborated with the Germans in building this road with the Soviet war prisoners. Many of them froze to death, 2,000 of them died.
I'm on Norway's remote Nordland line. After Mosjøen Station, we're heading towards the Arctic Circle, through a stretch of track with a dark past. 12,000 Soviet prisoners of war built the line for the occupying German army in World War II.
Just 100 meters from here, you can still find a lot of the rests of the prisoner of war camps.
So this was about supplies to feed their war machine.
That's right. Germans, they wanted to build it very fast because of the war. They pushed on and they used the same plans that the state-owned Norwegian railroad company, NSB.
This part of Norway, the winter conditions are extremely harsh. What sort of work conditions would these POWs have had?
They lived in very, very bad barracks and with very little food. On the top of the mountain plateau, there's winter storms, perhaps 40, 50 minus Celsius.
Yeah.
Many of them froze to death. 2,000 of them died.
The train is now at Saltfjellet, 680 meters above sea level.
As we enter the barren tundra of the Saltfjellet National Park, it's easy to see how the prisoners building this line would have been exposed to punishing weather.
We cross the Arctic Circle in just a few moments, and after that, we'll officially be in the Arctic. I've been looking forward to this part of the trip for a long time. It's really exciting.
You can feel it mentally. You're crossing a line to another world, the Arctic world.
And you will see the Arctic Circle Center on the right.
The train has slowed down because that monument that we are just passing now officially marks the Arctic Circle. From this point on, for the rest of the journey, we are way up in the Arctic.
As we enter the polar region, we're still a few hours from our final destination. The train is traveling north towards the Saltdalsfjorden. Then it will weave its way along the 40-kilometer coastline of one of Norway's most spectacular fjords, all the way to Buda. The route takes us back into rocky alpine forests, where loose rock risks damaging the tracks, trains, or both.
Maintenance crews are constantly clearing the tracks, but they also try to fix the problems before they start.
"200 kilometers down the line, an 83-ton section of loose cliff threatens to fall onto the Nordland track below.
If we don't fasten the blocks, then maybe rain, snow, ice, loosen them. They falling down on the trucks and make the trains collision.
The situation calls for reinforcement. The crew bores holes 1.5 meters deep into the rock face. A stick of super glue ensures the support rods won't budge.
These two components are mixed and then it's fastened about 1.5 minutes. This bolt alone prevents 16 tons from falling down the railway.
Even though we're in a polar zone, the northern summer sun is taxing the equipment.
Compressor can't get enough cooling. Too hot.
The team removes the engine cover of the machine, and a cooling breeze puts the compressor back on track.
You're drilling the nut, and then we tighten. Not too much, not too less. Now it's there.
Now this stretch of the Nordland line is protected from the rock above. In the running battle against the forces of gravity and nature, the Norwegian rail service has its prime directive: keep those trains chugging.
We have very powerful engines, and then run, and then run, and then run. Everybody knows that these locomotives, they are the Northern Line's soul.
The last stop on this line is Buda. It's got one of the most beautiful coastlines in the whole world.
And it's the perfect view to end an epic journey across two of Norway's most remarkable railways.
We're here in Buda, and this marks the end of our Norwegian train adventure. And in about an hour, this train's gonna do it all over again, after being refueled and topped up with supplies, on an overnight run back down to Trondheim through the land of the midnight sun.
In Italy, style isn't just for runways. Here, fashion is on the fast track.
This thing isn't messing around.
Meet two champions of the rails, the Frecciarossa 1000,
and I can't wait to feel the speed of this train for myself.
And the Italo Evo.
Designers look to sports cars for inspiration.
These high-speed marvels must journey through landscape that's as stunning,
you almost can't believe that there's a train line here at all,
as it is treacherous. And laying new track can be like going into combat.
Join me as we crisscross the country aboard not one, but two of the fastest trains on Earth.
All across Europe, from the city to the country, going places is getting faster and faster.
Italy is known for its food, its architecture, its beautiful scenery, and most importantly, its high-speed trains.
Italy is the only country in the world to boast two competing high-tech, high-speed train lines.
High-speed rail is very, very competitive. That was a rivalry that was very, very strong.
Quando vuoi andiamo. Perfetto, grazie. Ciao.
There's the government-owned and operated Frecciarossa 1000, the fastest train in Europe.
300 kilometers per hour, maximum comfort. What else?
And its sleek rival, the privately owned Italo NTV Evo.
May I ask you a ticket, please?
The Frecciarossa and the Evo compete for customers every day, side by side, at the same stations, on the same tracks.
We have to take in consideration there's an infrastructure, like an airport, and on the same infrastructure, we have two companies.
In a single year, 64 million Italians and visitors ride these high-speed wonders. And now, I'm going to join them. Later, I'll be zooming on the Evo through the alpine foothills of northern Italy, from Venice to Turin. But first, I'm riding the Red Arrow, the Frecciarossa 1000, which is whizzing south from Milan to Naples. My high-speed journey begins at Milan Central Station.
A o 5B come meglio preferisce, alle posti 1B o 1C.
Ah, ok.
Va bene?
Ok, perfetto.
400,000 daily passengers make this station Europe's busiest. Some are here to ride the fastest train on the continent.
I love this job. I chose it. It's great.
Daniele Lazzarin is about to take over the driver's seat.
Ciao.
Ciao.
Tutto a posto?
Sì,
Perfect.
His colleague coming off shift confirms there's been no technical issues. The train is working perfectly. The Frecciarossa is bi-directional. This cabin has been powered down. Daniele will pilot from the cabin at the other end.
Now I have to close the door for security reasons. And then we need to go on the other cabin for the departure.
He has to be ready to leave in 15 minutes.
It's pretty long. It's almost 400 meters, so we have to walk really fast to get on time and start on time. The most difficult part of this job is that you have to be focused for long hours. You wake up very early in the morning, but after a while, you get used to it, and it's pretty cool.
Daniele signs in with his secure passcode.
This is my license. I have to pull it over here. This is the black box, I guess, of the train. Everything that I do is registered over here. Every day is different. The shift is different. It's never boring. It's never monotonous. I will never get sick of this job.
The Frecciarossa 1000, or Red Arrow, is 202 meters long, 2.9 meters wide, and 4 meters high. The 8-car train can seat 457 passengers. Capacity doubles to just over 900 when trains are joined. The Frecciarossa does not have a dedicated locomotive. Instead, each train has 4 cars fitted with 16 electric motors. With 2 trains combined for today's journey, 32 motors will power the ride.
Here's where the trains kiss.
Conductor Matteo El Chakra takes charge of nearly 600 passengers.
I like taking responsibility, so whenever there are any kind of problems, I have to act on it.
7B, signore avanti, la sezione B avanti.
I like being the person that people go to if they have a problem.
As for potential problems on the track, the Frecciarosa's maintenance crew is on the case, working some 800 kilometers south in Naples.
Ciao Mario, il test è già iniziato?
Sì, già iniziato e per adesso è tutto regolare.
All the trains that come into the depot, they're expected to go out on time because they need to respect the schedule. So it's a very important factor that, you know, that as soon as the train gets in the depot, we already know what to do. We already have components by the train, we have already people there.
These are the overhead pantographs that draw electricity to the train's transformer.
E ti sgancio questa. E tu sali di qua. What's the switch? It's where you get the power from. So if you don't maintain it properly, you can cause damages to the overhead line, you can cut it, so you can cause disruption to the service.
Each axle on the train is inspected with an ultrasound probe. This uses sound waves to generate a precise image from deep inside the axle.
With this machine, we put a probe into the axle and discover if there is any defect or any crack. This is so important because we cannot allow any little defect being in the axle, especially in high-speed trains.
Mancano altri 10 assi per completare il convoglio.
Perfetto, allora poi ci mandi il report.
Certo. Ciao.
Once a train passes inspection, it goes back into service, ready to roll across the country. In Milan, Matteo gives a final warning to any remaining passengers on the platform.
The final moments before departure are really important for the train staff. They have to get the passengers on board, do their final safety checks, and make sure the tracks are clear before they can get the green light to start our journey to Naples.
Abbiamo un giallo con indicatore 6, quindi siamo pronti a partire.
Right on time, the Frecciarosa 1000 departs from Milan.
Now I have to do a little brake test.
Before the train can hit its stride, Daniele must perform a critical safety check.
Once the train got a little speed, like 70, 80, I have to brake and to feel the train that it brakes, because this train will run to 300 and we have to be very, very sure this train will brake.
If the brakes fail the test, Daniele would have to return to the station. That would just be frustrating. If they fail at high speed, the results could be catastrophic.
Now I'm braking over here. I can feel the train and it's pulling a little back. So it's okay, I'm okay. We are okay to go to 300 kilometers.
And we're off on the first half of our Italian adventure. From Milan, I'm heading nearly 800 kilometers south. First across a vast stretch of flatland called the Pianura Padana, then on to Bologna. From there, I'll travel through the Apennine mountain range to Florence, on to the capital Rome, ending at Naples, located near a volcanic region called the Phlegrean Fields. The trip will take 4 hours, 20 minutes. It's a whole new way to travel the country by train.
I used to live here, and 30 years ago I rode the trains back and forth, but they were 5.5 hours long and I had to stand, and sometimes there was a pig or a sheep on the train, and so this is very different.
This is very different. It seems like Italians have a bit of a thing for speed, you know, whether it's really fast cars or this state-of-the-art train. What do you think it is about speed?
It's because we're always in a hurry, that's why. We need to go places quickly enough, that's why.
15 minutes outside Milan, Daniele prepares for maximum speed. The Red Arrow's rail path is a chain of conventional and high-speed sections, the equivalent of a straightaway on a racetrack.
Now we're approaching the last regular signal. I have to confirm that I know that we're approaching the high-speed line.
There's no obvious physical difference between the tracks on the high-speed and conventional sections. But high-speed sections are straighter with shallower curves.
And right now I'm changing the voltage over there.
The real difference between sections is the amount of power the train uses. To run at high speed, the Frecciarossa has to increase from 3,000 direct current to 25,000 alternating current.
And when everything's set, I can drive the train to 300 kilometers.
As those 20,000 extra volts charge into the train's motors, the red arrow begins to fly. To the people outside, it's a blur.
And the feeling of bringing these powerful things to this speed is unexplicable. It's cool.
The Frecciarossa's engineers have done a spectacular job. The ride is so smooth, passengers are unaware of the increase in speed.
They don't notice the speed. They don't notice the speed. People just are we really going at 300 kilometers per hour? Answer, yes, we are.
Yeah.
Are you feeling the speed right now?
It's incredibly smooth. It's smoother than most trains, actually.
It is.
Yeah.
It is. So people don't believe that we're going 300 kilometers per hour because it's impossible. I feel nothing.
We're speeding along in total comfort and safety. But even the smoothest train ride can end with a terrible jolt. I'm in Italy, on board the high-speed Frecciarossa 1000, the fastest train in Europe.
The Italian landscape is already so beautiful, and it's going by so fast. Our first stop will be Bologna. That's coming up soon.
From Bologna, we'll go south through Florence, then Rome, until we reach Naples.
Where are you headed?
Rome for today.
Cool. Why did you guys want to take this train as a family?
Because walking would be too slow.
Oh!
As Daniele approaches Bologna, he begins braking 4 kilometers from the station. That's how much distance he needs to bring 1,000 tons of train, plus cargo and passengers, to a smooth and safe stop.
Now I have to speed down a little bit more.
The Frecciarossa relies on a combination of pneumatic and electric braking. When Daniele gets the braking process started, the computer engages the electric brakes, cutting off power to the motors, which now create a resistant torque that slows the train. As the train gets closer to the terminal, the computer then engages the pneumatic brakes, where brake pads press against brake discs mounted on the axles, just like a car. The train relies on electric braking at higher speeds and on the pneumatic brakes at lower speeds. Bringing the train to a stop and holding it in place at the station.
We're in Bologna, it's an underground station.
Bologna is also headquarters to a critical command center.
There are 2 trains that are being serviced for passengers in Bologna station.
35918 esce da Bivio Venezia, il primo è il 9536.
It's a very busy line and for a high-speed line. Every day we have 250 high-speed trains that reach the maximum speed in these track lines.
CL sia a Rifredi che a Castello.
We are also increasing the number of high-speed trains that are programmed in circulation.
These controllers are trained to respond to minor and major traffic disruptions.
The issue in these situations regarding trains has to do with where the trains will stop, how the continuation of the trips will be handled for the passengers, while ensuring their security.
Unfortunately, some disruptions are horrific. On August 2nd, 1980, this station became the site of one of the worst terrorist attacks in Europe's history. At 10:25 a.m., a bomb was detonated.
killing 85 people and injuring more than 200. And to help people here remember the victims of that day, the clock permanently marks the time of the attack.
After Bologna, no one takes safety for granted in this country.
We have the authorization, so let's go.
Back on the platform, our Frecciarossa 1000 leaves Bologna on time for Florence, Rome, and Naples.
On this track, there are lots of trains, so it's really important we keep on time, otherwise it will affect the other timetables.
Matteo heads to his cabin where he can keep an eye on the entire train, receive alerts, and adjust the temperature of each coach with the tap of a screen.
So right now, and I'm sure you're not feeling it, we're going at 297 kilometers per hour. Just wait a few seconds, and Daniele up there will reach the 300 kilometers per hour maximum speed. So 299, and go for 300.
Matteo's right. At 300 kilometers an hour, this ride is smooth and stable. And given Italy's rocky terrain, that's nothing to take for granted.
I'm excited to get up in the air. All right, here we go.
In Italy, track work is often done at locations so difficult to access, crews need a helicopter.
As we follow this part of the coastline of the Italian Riviera, we're seeing part of Cinque Terre here, the Five Lands. It's an incredibly popular tourist spot.
A crew is working here to protect a section of track and tunnel from being washed away.
You can actually see a train going in the tunnel. A train just passed by there. And you can see all the fences that are stopping rock slides because the train runs directly below us. And I mean, you just looking up there, you almost can't believe that there's a train line here at all.
This team has to divert a river that often floods this tunnel.
Metti in moto, occhio, eh?
The river dries up in the summer, so crews have a short time to get the work done. Geologist Fabio Rivolta works for Rete Ferrovia Italiana, the national corporation that maintains Italy's rail track.
Even just getting down here is a challenge, but we're going to take a closer look at what the workers have been doing down here. Wow, so we're on the side of a mountain, giant cliff walls, and the train runs right through this tunnel here. It's really amazing. Where is the river right now, and where are you moving it to?
The river usually runs here, and then in normal conditions, it would continue to run across this little bridge. In extreme situations, like a flood, the river runs over the tunnel and the falls in this area.
While trains roar by, the crew will divert the river. It's a big job that will take weeks. We're only here for a small portion of it.
Here, the work is always in progress. There is always another new intervention, a wall that needs more securing, a river that needs fixing.
Without crews like these, our Frecciarossa 1000 would slow to a crawl. Back on our trip, we're about to gear down.
We are in the connection from the high-speed line to the station of Florence.
The Frecciarossa is capable of reaching 400 kilometers per hour. But driver Daniele has to make sure he stays at the speed limit set by the government. For now, that's 300 kilometers per hour.
This is the safety device that tells me that I'm a little higher than speed. Just a couple of kilometers per hour more, and it tells me that I have to brake. If I don't brake it, it will do it until a complete stop of the train.
The Frecciarossa 1000 comes equipped with various other safety devices.
Every 50 seconds, I have to push it, and if I don't do it, because something happened to me, to the drivers, the train will stop completely. And we don't have just the pedal, we have 8 other points, like the brake, the horn, and other points that I can touch to reset the countdown of these 50 seconds.
Then, just outside Florence Central Station...
Wait a second. Something happened. We have no power.
The train has already started slowing down. Back in his office, Matteo also receives an alert that the train is quickly losing speed. Daniele knows there's another train behind him, just minutes away. They need to find out what's going on right now.
Is everything okay?
We have no power.
Just outside Florence, the fastest train in Europe has suddenly lost power.
Something happened.
Driver Daniele Lazzarin needs to figure out what's going on. Conductor Matteo El Chakra has nearly 600 passengers on board. They expect to arrive at their stops on time.
Lì hanno dei problemi di alimentazione nel nodo, gli vanno via.
At the control center in Bologna, the delay is real cause for concern. If it doesn't get resolved soon, dozens of trains using the same line could be affected.
Quindi vediamo un po', perché è ancora 40 minuti di tempo, una freccia in ritardo che potrebbe avere un conflitto con un regionale verso Orte.
Fortunately, it doesn't take long for Daniele to figure out what happened.
Something happened to the voltage over here, and now it's everything okay.
The train was drawing too much power, so a circuit breaker automatically kicked in.
There's a protection that will cut all the voltage for like a couple of minutes. Everything is up and running again.
The Frecciarossa roars back to life. It's a huge relief. Rome is our next stop, 230 kilometers away. With the passage of each kilometer, Daniele is alerted to any signal that could compromise safety.
They teach us every day, every updates, to put safety first.
And he depends on the tracks below him.
Stiamo organizzandoci per l'attività, le fasi di volo sono state stabilite, il posizionamento del drone.
100 kilometers north of Rome, near the town of Orvieto, a team of engineers gather at the Paglia Bridge, built in the 1960s.
It is important to analyze the stability and the safety of the bridge.
The team has been sent by the government-owned Rete Ferrovia Italiana, or RFI. It's responsible for Italy's track network.
RFI has to inspect each bridge annually. We have to inspect all the components of the bridge. This is an experimental activity because today the drone cannot fully replace the inspection performed by an engineer, but it's a valid support to an engineer.
And the drone will allow the crew to inspect the bridge without disrupting traffic.
Today we are performing a side flight in order to acquire all the data of all structural components of the bridge.
From the drone's eye view, there could be cause for concern.
Now we are seeing there is a corrosion at the base of the concrete pillar, and we can see the presence of water infiltration.
Large infrastructure requires constant inspection. Over time, minor issues can grow into major problems. If unchecked, a defect can cause corrosion of the reinforcements in the concrete. The RFI crew is here to make sure that doesn't happen. They rely on a mixture of real-time footage relayed to their monitor, as well as thermal imaging to reveal any structural issues.
From the ground, we see those defects that looks like a crack.
A serious defect could shut the bridge down for repairs, or worse.
Quello che vedi davanti a te, quello più alto.
After closer inspection of the footage, it turns out that the water damage is not a cause for concern.
This defect is quite light and don't affect the stability of the bridge. We have to know where is this defect so that we can plan the ordinary maintenance intervention to remove it.
The vast high-speed network depends on the government's constant inspection process. Meanwhile, the Frecciarossa 1000 is closing in on Rome. The drive from Milan typically takes 6 hours. The Frecciarossa has covered the distance in 3.5 hours.
Thanks to these high-speed trains, we gave the Italians a chance to live in their homes and work in other cities. We have people going to Milan in the morning and come back in the evening and go to their families.
We are almost in Roma Termini. I'm now approaching the station at a slow speed.
We're a bit behind schedule, so we gotta hurry up.
To depart the terminal, Daniele has to go back the way he came in. This means piloting from the cabin at the other end of the train.
And we have to leave in a few minutes to Naples, which is our final stop.
Running a few minutes behind schedule may not sound serious, but delays ripple down the track. And for the crew, staying on time is a matter of pride.
I'm confident that I will make up the time in Napoli Centrale. As always, we have to do a little connection from here to the high-speed line.
The Frecciarossa's speed depends on a stable track bed below. Constant upkeep of infrastructure can prevent major problems on bridges and tunnels. But some problems are utterly unpredictable. As we speed from Rome to Naples on board the Frecciarossa 1000, we're traveling over countryside rocked for centuries by shifting tectonic plates. Earthquakes are really common here in Italy, so when the entire high-speed rail line was designed, it had to be built in order to withstand the powerful tremors that rock this country hundreds of times each year. There are no earthquake sensors on the train or tracks. Instead, tremors are monitored in real time by Italy's National Earthquake Center, and alerts are sent out to the train lines. Drivers have to respond immediately.
The only thing that you can do is activate the emergency brake and stop the train.
Stopping a train far from a station carries its own set of risks.
There could be another train going on the other side, but you have to be sure, absolutely sure, before you unlock the door, and we have to get a permission about that. If this happens inside a tunnel, there are some certain points that we have to stop in order to evacuate the place.
Speeding from Rome, the ground is stable today. We arrive on time at our final destination of Naples.
Now we're arrived in Naples, in Napoli, and the last thing I have to do is check that nobody is on the train, that nobody left their luggages. Okay, we're ready. The train is empty, nobody's aboard, and I guess I'm done for the day.
And so is Daniele. They'll hand over to another crew who will guide the train back to Milan.
Daniele, thank you for the trip, my friend.
Yeah, hope everything went good.
Oh, it was a great ride.
Enjoy a ride?
It was
Okay.
incredible. Well, this is my first time here in Naples, and this marks the end of this journey. But we're not done yet. Next, I'm headed to Venice to ride another one of Italy's high-speed wonders.
The second half of my high-speed adventure begins just steps away from these famous canals.
Allontanarsi dalla linea gialla.
Our journey begins here in Venice. We're jumping on board a high-speed train that was inspired by Italy's sports car culture and love of racing. That train is the Italo Evo.
The Evo is 187.3 meters long, 2.8 meters wide, and 4.1 meters high. It can carry up to 480 passengers in its 7 cars. The train reaches a maximum speed of 250 kilometers per hour. 95% of the Evo is made of recyclable materials.
Buongiorno, Teddy. Hello, hello. So you're driving the train today, but you're training the new drivers for this brand new train. It must be a thrill for you.
Yes, it's amazing job.
Launched in 2017, the Evo is so new, even the drivers are still getting used to it.
E questo è l'isolamento del freno a moto, del distributore, scusa, e isola tutte e 2 carrelli.
On this trip, trainer Giulio Berti needs to be sure driver Sebastiano Serpico is up to speed.
Okay. Guidare un treno.
Driving this generation of train is the culmination of a lot of hard work, with 2 years training to reach this goal. A lot of sacrifices, a lot of studying, a lot of training. It's what you have to do to achieve this goal. So, driving this train is the reward of so many sacrifices made. Numerous hours studying, numerous hours of training, so it's a very emotional moment, but really nothing more than the reward of reaching a goal that you've been looking forward to for a long time.
The last passengers are aboard. With all the preliminary checks done, it's time to roll.
Welcome on board Italo 8972 from Venezia Santa Lucia to Torino Porta Nuova.
I'm traveling 400 kilometers across northern Italy. I start in the city of Canals, Venice, and move west, skirting the foot of the Alps into wine country, through Padua, onto Verona, Brescia, and then to the largest city in the north, Milan, before finishing in Turin. The trip will take 3.5 hours.
Signori, buongiorno. Vi chiedo gentilmente la prima lettera del codice biglietto, per favore.
As the Evo speeds away from Venice to Brescia, Sebastiano has to prove he can follow all procedures while keeping his passengers safe.
Sebastiano is making sure the tracks are clear, even if the signals say they are. So we've got more than 8,000 meters free ahead of us for now.
Certainly at the beginning it is more difficult to manage all the controls. Then you get used to it. It becomes routine.
It's not just the drivers under pressure. This team at the Evo plant is charged with assembling one of the most high-tech trains in the railway world. Their inspiration? One of the fastest cars of all time. I'm riding the Italo Evo, the train that's rocking the high-speed industry in Italy.
It's the first case of a private company in open access competition against other public state-owned companies. So it's very interesting business case. It's the first in the world and of course is working very well.
When designing this train, making it fast and functional were the most important factors. But making it sleek and stylish were also at the top of the list. So designers looked to sports cars for inspiration to make the Evo stand out wherever it goes. It's incredible that this train that we're on, this is how it started. You and a sketch pad.
Yeah.
It's amazing. It's amazing.
Xavier Allard is the Evo's lead designer.
The main ideas concerning Evo came from the legend Ferrari P4, 1967. And the fantastic cars with very, very beautiful curves, very beautiful shapes.
The Evo's racetrack red evokes Italy's motorsport glory.
So the reference belonging to the past, but expressing also the modernity, something from today, something from the future.
These designs were the first steps of an epic journey that leads to northern Italy and the Alstom plant in Sivigliano. Here, 300 workers spend 40,000 hours building an Evo.
We can perform the cutting of different components, such as brackets, plates, of different materials.
At this workstation, it takes 3 days to weld together the walls, floor, and roof for a single coach frame.
We check 100 physical points inside and outside of the car in order to be able to understand if the welding and all the complete car is respect the technical tolerances reported in our drawings.
Before being put into service, every system on the Evo is put through multiple tests.
Mattia, allora accendiamo le luci anabbaglianti. Ok, spegni. Vai di nuovo, abilita il freno. Ok, perfetto.
Evos are built to run more than 500,000 kilometers per year without the need for heavy maintenance. The Evo's nose is a signature design feature, but there's more to it than meets the eye. In the event of a head-on collision, the Evo's nose has been designed to provide maximum crash protection. Inside the nose are 4 crash boxes composed of layers of steel. On impact, these boxes collapse, absorbing and displacing the oncoming force. The boxes also provide a protective barrier between the driver and the object of impact.
Signori, buongiorno. Chiedo gentilmente la prima lettera del codice biglietto C di Como.
We're an hour away from Milan. Under the watchful eye of his supervisor, Giulio, driver Sebastiano is still working to get fully certified.
If a person's been trained, there's nothing to worry about. Every supervisor should check on their employees. It's right that safety should always be guaranteed.
Even when there's testing involved, there's no denying this is one of the best jobs in Italy.
We are traveling at 246, 250 kilometers, and driving a train like this is like driving a sports car, like a Ferrari or a Maserati.
At the beginning, one feels a great emotion reaching certain speeds like 300 kilometers an hour. In fact, you suffer when you're not traveling at high speeds because you get used to this.
Sebastiano's progress, along with the entire fleet of Evos, is monitored by the NTV Control Center in Naples.
E dove sta questo treno? Vediamo che direzione sta prendendo.
Coordinator Paolo Capasso and his team rely on their diagnostic train tracer to analyze onboard computer systems in real time.
Our job is to see what the driver cannot see. We can see the status in real time of the main system of the train, high voltage, tractions, air conditioning.
On one train, the tracer has found something.
We have discovered a fault on the medium voltage of the train, which needs to be well investigated because it will be a problem on unavailability of air conditioning and all the comfort system on the train in a specific car.
Thanks to the tracer, maintenance crews know what they need to do before the train arrives.
So when the train comes in the depot tonight, we will already know what to do
to solve this problem.
This attention to detail and service is fueling the growth of high-speed rail. And the demand for more track grows with it. Construction crews are working hard to keep up.
A lot of really difficult and dangerous work going on inside, and right now we're headed into the heart of it. It's a massive tunnel.
I'm racing on the Italo Evo from Milan to Turin. The track beneath us crosses all kinds of infrastructure.
Between Milan and Turin alone, we're crossing 51 viaducts, 90 kilometers of embankments, and over 100 bypasses and overpasses, all within a relatively short stretch of track. And that translates into hundreds of millions of dollars of infrastructure.
And Italy's high-speed rail network just keeps growing. We're heading to just outside the city of Tortona in northwest Italy. It lies in a mountainous area close to the Alps, 80 kilometers away from Genoa. Welcome to the biggest construction project in the country, a brand new high-speed line.
We are talking about 53 kilometers of new railway. The value of this project is 6.2 billion euro.
This new high-speed line will slash travel times for cargo moving between the Mediterranean and the North Sea. This means boring and blasting Italy's longest tunnel through 27 kilometers of rock.
Right now we're headed into the longest of these series of tunnels. All told, it's one of the largest construction projects in all of Europe.
Basically, we are digging these tunnels under hundreds of meters of rocks, up to 600 meters. Tunneling is always difficult, it's a challenge, but in this case it's even more complicated. In this region we have the transitions between Alps and Apennines, so which characterize this area as a very geological complex system, a tectonic line. Each day we can excavate about 20 meters, so it's a very fast production. In a month you can bore about up to 500 meters.
As the boring machine tears through clay, sand, stone, and silt, engineer Marco keeps watch for danger zones.
It could happen that suddenly in the excavation chamber we can have a lot of water, so we have to face with this problem, and it is very difficult.
And there's still another challenge confronting the crew.
Because this is Italy, obviously a country with really long and rich history, as the tunnel boring machine is doing its work and materials constantly being pulled out, sometimes they can even find a few surprises.
Decades after its end, World War II wreckage lurks beneath the soil.
We find a lot of bombs, American bombs, or we find some Roman tombs, or archaeological ruins that became from the Roman age.
As the tunnel presses forward, each section is reinforced.
A key piece of the tunnel boring process is this machine that presses these giant slabs of concrete up against the interior of the tunnel wall. It keeps all of the rock and debris from falling in. It's like a Roman arch.
9 slabs and a keystone are required to support a single section of tunnel. The entire tunnel project will require roughly 155,000 slabs and keystones. This new line is expected to be completed in 2023.
We built a new connection that changed the way to live, the way to connect so many people. And we changed the culture.
Meanwhile, my Evo has crossed northern Italy in a mere 3.5 hours. Before I know it, we're approaching Turin. Evo driver Sebastiano Serpico is ready to savor his passage from apprentice to driver.
It's the arrival at the station. The satisfaction that we've arrived on time for so many passengers and safely. Everything's gone well. It's the greatest satisfaction.
Sebastiano has passed his inspection. He's fully certified to run solo trips across the country.
Buon lavoro.
Grazie.
Complimenti.
Grazie.
Well, we've made it to Turin, and this is the end of our high-speed adventure across Italy. It's been a thrill to ride two of the world's fastest, most advanced trains across a country that's redefining high-speed rail.